Now we will try to learn how we transform a frequency based formula to a probability based formula. So considering the formula for x bar that we use, summation f times x divided by summation f. So now writing this formula down in terms of the variant I equals 1 to n terms fi xi divided by summation fi. Over here again I goes from 1 to n. So if we apply the sum on the denominator and the numerator, this is f1 times x1 f2 times x2 plus f3 times x3 up to n terms as n terms are involved, divided by similarly f1 plus f2 plus fn, and this is making the total number of observations involved in the data. Therefore, we can write it down further in this way: f1 times x1, f2 times x2, f3 times x3 up to n terms. Divide this by, we can simply write it down as n, that represents the total number of observations. Splitting all the terms involved in the numerator and writing it down as a separate divisor with n value, and up to n terms again. So what this makes f1 on x1 is in fact representing the probability of x1. So we can now change this entire expression with its probabilistic version as this. And finally, we can write this summation as xi times p of xi, where again I goes from 1 to n. Since the formula is represented in terms of probability now, therefore it cannot refer sample mean. Rather, it will represent the population mean, because probabilities or expressing something in probabilities gives us the generalized version of the variable that we are focusing on. So the left hand side variable was sample mean, but since this is transformed to probability, therefore the left hand side will now represent this. And now taking it, making it synchronized with our variable that we are dealing with, we have in fact constructed the probability distribution of x bar. Therefore, changing in the formula or replacing x with x bar in each term will give us a new formula that we can apply in our case. Or this can be simply written down as this. So this is how we can transform the formula for sample mean to the population mean by transforming the right hand side version of the formula from frequency based to probability based. Similarly, we can consider the formula for variance of a sample. We can compute or can be computed as summation f times x divided by summation f whole squared on x and minus summation f times x divided by summation f whole square. Using the concept of relative frequency again, we can highlight this component and we can highlight this component as well, and f divided by summation f in fact approximates probability of x. Therefore, we can now change the right hand side formula following the same logic what I have explained over here, we have discussed over here. So it is x summation x squared times p of x minus summation x times p of x whole square. Again, the left hand side of the formula, since it was given the formula as the formula for sample variance, s square was written and right hand side was structured in frequency terms. But since we have changed the structure of the formula, specifically right hand side of the formula to probability terms, therefore it should be a generalized version and consequently we can write it down in this way. This is referring now population variance of variable x or random variable x. Synchronizing this variance formula with our situation as in a similar way what I have transformed in this way earlier on. So sigma of x bar squared can be computed or represented as summation x bar squared times p of x bar minus summation x bar times p of x bar whole square. And these two formula we can now use to compute the mean and the variance of random variable x bar that we have computed on the basis of the samples drawn in case of sampling without replacement for a sample size of 2, then later on for 3, and then for sample size of 4.